So first, let's discuss just a bit of theory. GD&T typically does not add tolerances directly to dimensions. You can add them directly to the dimensions, but typically they use features. So think about a feature such as this plane. This plane has an angle to it, right? Angles are hard to define with plus minus tolerancing because theoretically it's always going to be 0 or 90, right? You're not really specifying anything in that case. Things like this cylinder, which has concentricity to this cylinder, right? Those concentricity values are geometric in nature. There's not really a plus minus value that can fully capture it. So geometric values such as roughness, flatness, angularity, it could even be something like concentricity or circularity, right? These are all things that are independently important, and it creates something that is both extremely precise and defined and sometimes almost daunting in terms of the relations that are being added, but it also ends up creating some really nice bonus tolerances, which is a really interesting thing. Now, quick disclaimer, I'm not showing you how to interpret GD&T. I'm not teaching you how to interpret GD&T. That's a long process. So we're just going to cover just the very basics, and if any of this is wrong, you'll have to forgive me because I'm doing my best to understand it, but GD&T is a specialty all by itself. So another thing we use a lot with GD&T are datums, meaning this part, let's say this part, the spacing from here to here is wrong. Does that mean that this face was made wrong, or does that mean that this face was made wrong? One of them has to be made wrong. And a datum basically solves that and says, this one, if that's our datum, that's the correct one. Everything else is wrong based on that one, right? And so it's very clear where you're supposed to measure to and what exactly to align this part to. With a datum, you can kind of also think of it in terms of setting it down. So if I were to set this down on a table, right, the 3 points on this that hit the table first, those are the 3 points that determine its orientation. So if you've got kind of a bump here and a bump here and a bump here, and those 3 settle down and those are the 3 that it's resting on, that's the official orientation of this part, which is pretty critical. In the case of something like a cylinder, it's the axis or the center of it that is what's critical. That axis is going to define everything. We also use basic dimensions. Those are just dimensions with boxes around them. Those are nominal values. They don't really have a tolerance applied to them because they're telling you what the truth is. The tolerance will be applied separately. And finally, we have control frames, which is where a lot of the work is being done in terms of the tolerances, because you're at that point you're comparing features and using geometric values to say that those two are related to each other.